Morning students, today I am going to start the major part uh, of your mathematics, that is calculus, integral calculus, differential calculus and their application. Major part means 40 marks question will come from this section, calculus. Differential from differential equation, differential calculus means differentiation, its application means maxima minima to measure rate and integration and its application. So I am going to start first of all differentiation of function. In the continuation of differentiation, since some basic portion already has been covered in class 11th. Okay, so I hope so that you all are well known about the basic formula. I am not going to write the basic formula, but some basic concepts I am going to recap it. Differentiation is basically the process to calculate first differential coefficient or second differential coefficient. Basically, it is the process to calculate differential coefficient. Like if a function, what is differential coefficient? I am going to start from here. If a function y is if y is a variable and it is depending on x, means there are two variables x and y. X is known as independent variable, y is known as dependent variable. Since y depends on x, okay, therefore y is said to be function of x. Alright, it means if this x will change, y will also change. So let's see, let x changes by some quantity, let h, then h or delta x. Suppose I am writing first of all delta x, later I will change into h. H is a very small quantity, or delta x is also known as a very small change in x. So let x changes by delta x or h, then y will also change. Let y changes by delta y. Thus from here it implies that equation number 1, let here y changes by delta y when x changes with delta x. Okay, like this. From here it is obvious, subtracting equation 1 from equation 2, what we get? Y plus delta y minus y is equal to fx plus delta x minus fx. Okay, from here this will cancel out. So delta y, this is the change in y. It implies that change in y is equal to fx plus delta x minus fx. It is obvious that this change in y is due to change in x. So we want to find the rate of change of this quantity y with respect to change in x. So dividing by delta x, since in delta x is the change in x, it implies that fx plus delta x minus fx divided by delta x. But if here the condition is that this change in x must not be very large, it must be very small. It means its a limit delta x tends to 0. So taking limit both of the side, delta x tends to 0. This quantity, just see how can you define this quantity. Is defined as the rate of change of y. Y means a dependent variable. The rate of change of y with respect to very small change in x. Is it clear? Rate of change of y with respect to very small change in x. So this whole quantity is known as dy by dx, and this is called first differential coefficient. First differential coefficient. This is called first differential coefficient, and this process to get this one is called differentiation. So this limit delta x tends to 0, f x plus delta x minus fx divided by delta x. Sometimes we take this small change delta x as, let delta x is equal to h. What is h? It is obvious that this h is very small quantity. I am for symbol only, that for small symbol we can use. Thus this dy by dx is also known as limit. Here h tends to 0, since we are replacing delta x by h. So h tends to 0, fx plus h minus fx divided by h. This is the formula to calculate, actually this like this, limit h tends to 0. So this is the formula to calculate differential coefficient, or in more general first differential coefficient by first principle. Okay. So every time if you have to calculate differentiation of any quantity with respect to some other, then by first principle we can use this formula. How it came? It is obvious. Okay. Now let's see some of the questions here by using first principle. Let's see its application, that how can we find first differential coefficient of some functions by using this formula. Let's see. If y is equal to a constant, here c is what? A constant. It means y is c. Then how can we find its differential coefficient dy by dx? Let's see. Let y is equal to fx is equal to c. Is it clear? C for constant. Equation number 1. Now if fx is this, then fx plus h is what? Since we require this fx plus h and thereafter fx. What is h? H tends to 0. Now since this quantity is constant, therefore it is not depending on x, and hence whatever there is change in x, this quantity c will remain unchanged. Means here at this time also, it means x plus h means what? If anywhere there is some x, then at the place of x we can replace that x by x plus h. But here there is no x, so no need to replace it by x plus h. Constant value remain unchanged. Second. Now putting these values fx plus h and fx in basic formula. Formula is that dy by dx is equal to limit h tends to 0, fx plus h minus fx divided by h. That's why limit h tends to 0, fx plus h is c, minus fx is also c upon h. This implies limit h tends to 0, c minus c, 0 by h, and this implies 0 upon something is 0. This implies 0. So dy by dx of a constant implies d of, where if y is constant, it implies that d of constant upon dx is equal to 0. As you know already that what is the differential coefficient of a constant quantity individually? 0. You know already in the form of formula. So this is first formula is that d by dx of a constant quantity should be 0. But here one thing is to be noted down, that this quantity, the whole quantity, whole term must be constant, then only its differentiation will be 0. Now some more. Now some other method like differentiation of a function if it is multiplied with some constant. If some constant is multiplied with a function, then only the function will be differentiated, c will be taken out, means c d by dx of fx. Okay, for example, if you have to find differential coefficient of suppose 3 into x square, since you know the formula that d by dx of x power n, x is a variable, you need to know. If there is n is any constant, means it may be in fraction, maybe negative fraction, positive fraction, whatever, you can use this formula. But here some constant power, variable power constant, you need to learn this formula as some variable power constant. Then you can use constant in multiplication into that variable power constant minus 1. If you learn this formula like this, a variable power constant differentiation is equal to that constant will come in multiplication, thereafter variable, and here in power whatever the constant is that will decrease by 1. So just see, according to this rule, here this constant is not as a term, so its differentiation will not be 0, as I have written here that differentiation or differential coefficient of a constant quantity is 0. Here a constant quantity is, but it is not as a whole term, it is in the multiplication with a variable. That's why this will be taken out. Only you will differentiate this variable. Okay, this is not, this constant is variable power, so no need to take it out. Since if a constant is in multiplication or in division, then only it will be taken out, not in power. Okay, so see this 3, now x power n, at the place of n, c as per this formula n is 2, so this power will be in multiplication into x whole power, this 2 minus 1. Now 3 2 are 6, x power 1. So we know, don't write, we do not write power 1, therefore its answer is 6x. Therefore differentiation of this 3x square will be this one. Similarly, if there is another question here, differentiation of a function like 1 by 2 x cube, then how will you see here? Either you can see as x cube by 2 or 1 by 2 into x cube. So again this 1 by 2 is in multiplication, so it will be taken out and only the differentiation of x cube will be there. Therefore 1 by 2 into again x power n, like this formula, 3x power 3 minus 1. Therefore 3 by 2 into x square. This is your answer. Right. Some other rules. Some other rules like, if there is a polynomial and some more than 2 terms are there, or 2 or more than 2 terms are there, here just see a single term, here also a single term. Since terms will be defined by or separated by positive or negative sign, like suppose x square minus 3x plus x cube by 2, like this. Then this is one term, this is second term, this is third term. This total as a term, this is a term, this is a term. So if there are more than 2 or more than 2 terms are there, then either they are in addition or subtraction or in mixed, then we can differentiate them separately, and you have to find differentiation of this function. Then you need to differentiate separately, means this separately, and this one. So differentiation of this x square, the sign will remain unchanged. Thereafter differentiation of this 3x plus differentiation of this x cube by 2. Now you can use this one. x power n again, here 2 into x power 2 minus 1, power 1 I am not writing. So minus 3 is in multiplication, a constant is in multiplication with a variable, so this will come out only variable dx x power 1. So what will be 1 into x power 1 minus 1 plus 1 by 2 here can be taken out, and x cube means 3x power 2. Just see 2x minus x power 1 minus 1, x power 0, any variable power 0 is equal to 1. So this will become 3 into 1, 3. Okay, plus 1 by 2 means 3 by 2 here, 3 by 2 into x square. This is your answer. So conclusion is that if there are 2 or more than 2 terms written in addition or subtraction or in mixed sign, then each term will be differentiated separately. Nice. Next. If two functions are in product form or in multiplication form, like fx into gx, there are two functions, not one function. There are two functions, and sometimes we write this first function as u, second function as v, u and v, or sometimes we consider it as first function into second function. Okay, so if two functions are in product form, then we use product formula. What is product formula? Already you know, as d by dx of first into second function. First and second are functions like fx, gx, u or v, and like this. So d by dx of first and second, first into second is equal to first function into differentiation of second function plus, now second function has been differentiated, that's why now the chance to differentiate first. So see, first function into differentiation of second plus second function into differentiation of first, means if two functions are there, one by one each of the function will be differentiated and rest of them will remain undifferentiated and will be written in product form. Just like or d by dx of u into v, then u into d by dx of v plus v into d by dx of u. Either like this or like this you can learn this formula. I think in class 11th you have seen this all. And if there are three functions like first, second and third d by dx, then how will you? Then quite simple. One by one you follow this rule. One by one you can differentiate each of them. Like suppose you want to start differentiating from third. So first into second d by dx of third. Okay, plus third has been differentiated. That's why now the chance to differentiate second. So first and third will remain unchanged. Differentiation of second. Now third and second has been differentiated. That's why the now chance to differentiate first. So second into third and d by dx of first. Okay. So this is the way to apply the formula if two functions are in product form. For example, by taking some example, suppose x into sin x d by dx. See, there are two functions. One that is polynomial in x, means x is a function, and this is other function, algebraic function. This is a trigonometric function. Sin x, cos x, tan x, sec x, cosec x, cot x. These all are known as trigonometric function. And in x are polynomial in x is known as algebraic function. Okay. So x and into sin x. So two functions are there. Now how will you differentiate? First function into differentiation of second, means d by dx of sin x, plus second function that is sin x, write as it is. Now differentiation of first one. So how will you differentiate? X into differentiation of sin x is what? Cos x cos x plus sin x as it is. Differentiation of x is 1 as you know. So x cos x plus sin x. How differentiation of x is 1? X power 1 is here. So applying this formula, x power 1 means 1 into x power 1 minus 1, x power 0. That's why we are getting 1. Okay, so this is your answer. Now quotient rule. If two functions are not in product form, if two functions are not in product form but they are in division form, like fx upon gx, or like u by v, or we read sometimes numerator upon denominator. So we can learn our formula in the form of numerator and denominator. Simply in quotient form. So differentiation of a function in the form of numerator and denominator. So numerator upon denominator, that will give you here denominator into differentiation of numerator minus numerator into differentiation of denominator divided by whatever denominator, it's a square without differentiating. Only denominator will come here in the form of square. Some numericals, like if x upon sin x is there, d by dx. So this is equal to, see here, numerator upon denominator. So first denominator as it is, differentiation of numerator minus numerator is what, x. Here differentiation of denominator, that is sin x, divided by this denominator square. We write it like this. So it's here sin x into 1 minus x into cos x upon sin square. This is your answer. In this way, this is your quotient formula. Now, so now some numericals, like if 1 by x is there, d by dx, then how can you find? If x is not in, just like x power n, so this x, if x is in denominator, so just take it first in numerator. Just like, first of all, you can write it like x power minus 1. Thereafter, how will you? Now x power n is here minus 1. Therefore, x power n formula, n, x power n minus 1. So it implies minus 1 x power minus 2, or it can be written as 1 upon x square. So this is your answer. If there are some more numericals like x cube, if you have to find d by dx of x cube under root, then how will you? First of all, you can write this in the form of x power n. Now see, d by dx of x power 3 by 2. Okay, and now you can apply, this is your n. So n, x power n minus 1. Just see, this is your 3 by 2 x power 1 by 2. 3 minus 2 by 2, 1 by 2. It implies 3 by 2 under root x. This is your answer. Some more numericals I am giving you, like some more numericals like if it is like 3x square plus 5 whole power 9. Just see, if you have a question like this, d by dx, then how will you solve it? Quite simply, just see this. If some variable power constant, then this whole quantity is a variable one. You can consider it as x power n. Okay, and this is total x. Now how will you? X power n, meaning n, x, whatever x, that's total bracket is x. So this total bracket and power n minus 1 means power 8. Now into, since this is actually not x, you have assumed it as x. Therefore, later in multiplication, you will multiply with by differential coefficient of this quantity whatever you have assumed. So, what is its a differential coefficient? 3x square plus 5. So, here you can write d by dx of this 3x square plus 5. Now, just see 9 3x square plus 5 whole power 8 into differentiation of this. See, two quantities are there, two terms. So first and second individually. So see, what is this one? 3 is in multiplication with this one. So 3 will be outside. X square differentiation is 2x plus, and this whole quantity is your constant. Therefore, this term differentiation means differentiation of 5 will be 0. Since this is constant quantity, and whole quantity, whole term is constant. Here the term 3 is constant, but it is along with multiplication with x square. So its differentiation will not be 0. It will be taken out. While this 5 is individually a term, a complete term. That's why its differentiation is 0. Okay, so 9 3x square plus 5 whole power 8 into 6x. This is your answer. Or 9 6 you can multiply it. Okay. Some more numericals I am writing, and you need to solve first exercise 8th. I hope so. I am giving you some numericals. Okay, some numericals are there. You need to find differential coefficient, differentiate followings. 2x square, x plus 1 plus 2. How will you differentiate? You know well. First you multiply within brackets, and thereafter some terms you will get a polynomial in x, and thereafter individual terms can be differentiated. And here this one, first this upon this, and thereafter this upon this, and thereafter you can differentiate. Here this one, solve this, and by quotient rule you can solve it. And this by chain rule means first this you consider as x, so apply sin x formula, thereafter in multiplication differentiation of x square. And here this one, this you need to differentiate from first principle, as I have explained you earlier. Okay, so in next video I will explain next exercise. Thank you so much.